Well, hi everyone. This is SLU. I'm Bob Berman, and we're here to explore Comet Week. Welcome, everyone, especially those who are joining us from our 24-hour channel. That's the live channel that allows our members to enjoy around-the-clock entertainment from the folks here at SLU, from live telescope feeds to the best of SLU's past broadcasts, and even a few videos teaching you how to take advantage of the objects visible in the night sky. So we're here to explore comets this week. We have a special guest here that I'm very excited about. And let's start right off with, why comets? Why are they so special? And the answer, of course, is they've been astonishing people for thousands of years. It used to be bad news. Comets were not anything you'd liked to see because they supposedly brought bad luck. They were scary, and they're still awesome in not the sense that everybody uses that word. Recently, somebody at a 7-Eleven gas station asked me if I had exact change, and I said, "Yeah, here it is." And the guy said, "Awesome." And I said, "No, no, no, no. The Grand Canyon is awesome. Exact change is not awesome. But comets are awesome. And don't even ask me why. They're skimpy. They're mostly water droplets. They're ice. If you look at it on paper, you wouldn't think that they'd be so amazing, and yet you take a look at a good one, a bright one, and it is awesome. We've last had a really bright one back in 1996 and 1997 when we had two in consecutive years, Yakutaki in 96 and the Great Hale-Bopp in 1997. Once every 15 to 20 years, we get one that's called a great comet. And that adjective does not mean, hey, look at that. It looks great. It's an actual scientific term that means a comet bright enough to be seen by the naked eye without equipment, even seen over cities. So we were thinking that this comet coming up might have qualified, Comet Catalina, which is our focus today. And it doesn't look like it'll do that. We don't want to overhype this. We're going to be exploring this. It certainly looks fabulous. Look at this view that we're seeing through the SLU observatory telescopes. You can see a tail and an anti-tail going in an opposite direction almost. You don't get that very often. And often they have a series of tails. There can be an ion or plasma tail, a dust tail. Comets are very cool, and in color, as we'll see shortly, they can put on a nice green color. We don't see that with the naked eye. We will get later on in the show how you can observe this. Look at this green color. You won't see that unless a comet is super duper bright. We're not going to go there with Comet Catalina, but diatomic carbon, sometimes cyanogen, produces this green glow, and that makes it even more amazing because there are no green stars in the sky. And so having a green object, other than the aurora borealis, which is mostly green, it's pretty cool. So we like to study comets because they start off as a ball of ice or dusty ice. And then as they get closer and closer to the sun, of course, the ice would melt if ice could melt in space, but it can't because you need air pressure in order to have liquid water. So instead, it sublimates, it turns to gas, and the gas blows out from the core of the comet and streams for sometimes millions of miles into space. Really spectacular object. So this one, Comet Catalina, discovered on October 13th, 2 years ago, back in 2013, way far. At that time, it was 100 times fainter than Pluto. A really faint thing discovered by the Catalina Sky Survey. We're talking about photographically. Nobody saw it with their eyes. And then the orbit was calculated. It showed it had a very strange orbit. It doesn't return regularly. The only comet that we know that's bright that does that is Comet Halley every 76 years. It doesn't even have a long 17,000-year orbit the way Comet Hyakutake was found to have back in 1996. Although the inner solar system objects changed that comet orbit, perturbed it. So now its orbit is 70,000 years per return. No, this one, Catalina, is coming in one time, whipping around the sun and out again. It came from the Oort cloud, a spherical mass of comet reservoir icy objects, and this isn't even the Kuiper belt that's closer in. This is the Oort cloud way out there, so it's whipping around. We'll never see it again. Look at these great SLU observatory photos. You know, the major telescopes of the world are now looking at that over and over again, and each day it's looking different. It whipped around the sun, that is at its perihelion on November 15th, just a few weeks ago, and now it's on its way away from the sun, although toward Earth. We're going to have our closest visit with it on January 17th. In the meantime, it's going to pass near, it did it this morning, passed right near the planet Venus in the sky, and it's going to pass close to the star Arcturus, the famous spring star. We say Arctu, Arcturus. You follow the arc of the Big Dipper's handle. We'll talk about the dates and when that's happening, and a little later on the show, even how you can see the comet for yourself. These days, one thing you have to know, it's a pre-dawn object. You wake up before the sun rises, and there it is. Venus is there. The moon was right near Venus this morning, and next to both of them was this comet. How bright it is, it doesn't look great. I have to tell you, we thought it was going to be brighter. We thought it would be naked eye by this time. Back in August, it looked that way, but then it stopped brightening up in September, and now it's only sixth magnitude, which means that you really need binoculars to see it, or a small telescope, or take a look. These great SLU telescopes are doing it, and we'll get back to it and talk about comets and this comet in a little bit. But I'm so anxious to get moving to our interview with Jeff Chester of the Naval Observatory. For years and years, I've been subscribing to the Naval Observatory. Sure, I can calculate where objects are. And some of you may know that I'm responsible for the Old Farmer's Almanac every year, the almanac of it showing where objects are every single day. And I do most of those calculations myself. But to get the last word, because sometimes there's a little disagreement, I use the U.S. Naval Observatory's yearly handbook of astronomical phenomena, because this is the last word. So let's go to Jeff Chester of the U.S. Naval Observatory, and it's such an honor for me, Jeff, to have you here. Thanks for joining us.
Well, it's a pleasure to be here, Bob. We've got a beautiful day here at the Naval Observatory, and I'm really glad to hear that you're actually still using some of our paper products, because we don't have too many people that still do that. A lot of our information is actually available online, but it's still nice to know that there are some folks who still like to have that old-fashioned technology of a book in their hands for when their Wi-Fi connection doesn't work or something like that.
Absolutely, just love it. I'm one of those. I'm a pilot, an airplane owner, and the same thing with charts, aeronautical charts. Got to have that stuff you can hold in your hand and smell it. Naval Observatory handbook has a nice smell to it every year. Love the smell of that fresh ink. But tell us a little bit about the Naval Observatory. What's your mission?
Well, our primary mission is twofold, and it actually hasn't changed much since our inception. We actually yesterday had our 185th birthday. On December 6th of the year 1830, the Secretary of the Navy issued orders to a young Navy lieutenant named Lewis Goldsborough to establish in Washington a depot for the proper care, repair, and rating of all of the Navy's navigational instruments. In order to do this, we had to, first of all, establish positions of stars so that we could use those positions to determine a time scale. Once we had that, we could then use that time scale to calibrate all of the Navy's ocean-going clocks, the so-called chronometers. So our mission is basically the same today. The difference is that today we use the most modern technology to produce the most precise products in both the fields of astrometry, which is the positional measurement of celestial objects, and precise time. For instance, the timing that we are producing now is what makes our current conversation and your webcast entirely possible. Without the timing that we get from the global positioning system, that synchronizes all of our networks and allows us to use the particular features we're using right at this minute to talk to each other and to see each other and to distribute it around the world. So that is the primary mission. We're not really that glitzy as far as pictures of deep sky objects and that sort of thing go, but we like to think that we are primarily responsible for all the structure that astronomers use to define where things are in the universe and when they happen.
Now, I love that. Now, you brought up the GPS satellites, and I understand you do the positioning of that. What does that mean exactly?
Well, what we provide is the timescale reference for GPS. As you probably know, GPS operates essentially by taking very small time differences from a number of different satellites that are in circular orbits roughly 12,000 miles overhead. There is a very slight difference in arrival times from the atomic clocks on board each of those satellites. And that is what tells you where your position is on the surface of the Earth. The problem is that each satellite has 4 atomic clocks on board. And yes, they're atomic clocks, but they don't necessarily run as perfect clocks. So our job today is to do exactly what we used to do with marine chronometers in the old days, and that is to use a defined standard time scale to calibrate every single clock on every GPS satellite. Now, back in the days of chronometers, we could do this using transit circle telescopes and measuring the positions of stars. Today, we use ultra accurate atomic clocks. Our current atomic clock system has a mean timescale resolution of better than 1 nanosecond per day averaged over the course of a year. That's 1 billionth of a second, plus or minus, over the course of a year.
Now, when you say the atomic clocks in these satellites, they're not actual cesium fountain atomic clocks. They must be some sort of portable type unit, right?
Yeah. Yeah, they actually, what they use are what are known as chip scale rubidium clocks. We actually use rubidium because it keeps better time in some ways than cesium does. The atoms of rubidium are smaller, and therefore, when they bounce off each other, they don't recoil as much. Now, time scales, the definition of the second is actually maintained by our friends at the National Institute of Standards and Technology. And since the second is defined in terms of a set number of oscillations of a cesium atom, they have to use cesium. But since we're not interested in absolute time scale, we just want to have the most precise clock that's possible. We can use other devices. So we use a combination of cesium beam frequency standards that are kind of off the shelf. We also use a number of hydrogen masers. And we have recently built and are now running 4 of our, actually 6 between us and our alternate master clock, 6 rubidium fountain clocks, which are designed to operate for 10 to 15 years before we need to do work on them.
Oh, this is just all so amazing. Thank you for clarifying that. All the science geeks of the world have, of course, memorized that famous definition of a second that has to do with the cesium-133 atom. I'm sure you know too. 9,192,631,770 cycles per second. That defines the second. That defines the second, doesn't it?
Absolutely. Now, when I first started working here over 18 years ago, I always thought a second was one Mississippi, but they beat that out of me pretty quick.
Great. Now, do you still, here's a question. Do you still require naval cadets to learn the stars, the constellations and the stars? Is that, or has that fallen into being obsolete?
Well, it was interesting because, of course, if you go to quartermaster school, those are the guys that actually do the navigation. So they've had to practice celestial navigation all along, because believe it or not, celestial is still the only viable backup that we have to GPS. Um, since they've done away with the Loran system, we no longer have any electronic aids that we can use. So it's gone back to good old-fashioned celestial navigation. Up about 10 years ago, they stopped teaching celestial navigation at the Naval Academy for upcoming officers, but they reinstated that within the past year as part of the regular curriculum for all the Navy cadets. So I'm glad to see that it's coming back.
I'm glad to hear that too. Now, since you said I'm glad to see, talk about yourself for a minute. What sparked your interest in space and astronomy and the things you do?
Well, I have to go back to when I was 7 years old, which was now a long time ago. So I like to say back then the Dead Sea was just sick. But sorry, this is why I have a day job. But I looked at the moon one night through my dad's binoculars, and I think I was about 7 years old, and I suddenly realized that the moon was just not this thing in the sky, but I could see the craters and stuff along the Terminator, and I realized that the moon was actually a place. And then I got for Christmas one year a copy of Patrick Moore's Picture History of Astronomy, and that really got me started. So I developed a passion for it by the time I was 10 or 12. And when I was in high school, I just devoured science, physics, astronomy, and ultimately wound up going to Worcester Polytechnic Institute up in Worcester, Mass, and getting a degree in physics from them. And I've always been interested in popularizing astronomy. I didn't have the time, patience, or money to keep going for advanced degrees, but I was able to land in Washington and ultimately worked for almost 20 years for the planetarium at the Air and Space Museum downtown. And then the position for public affairs officer opened up here, and it was the only natural move that I could make. That plus the fact that my great grandfather was actually the superintendent from here from 1902 to 1906. They
You're
told me it had
kidding.
nothing to do with it. No, it's in the genes. It skipped a couple generations, but they told me it had nothing to do with my getting the job, but it probably didn't hurt.
Oh, that's so great. Jeff, we're going to have to stay in touch, of course. We talked about that before the show began. And thank you so much for joining us. This was really a
You're welcome.
pleasure. Jeff Chester of the Naval Observatory, while we look at these great images of Comet Catalina. We're going to take a short commercial break right now. When we return, we'll learn all about how ancient cultures looked at comets. And I'll tell you the very best way to see this comet for yourself. But before we go, I just want to tell you another exciting show coming up this week as Comet Week continues. On Thursday, Will Gator, SLU's astronomer Will Gator, will be taking a look at Comet 67P, and we'll be looking back at Rosetta's year of the comet. Remember that with the device on it that popped in the air and landed nobody knew where, and what's happening with Rosetta. So we're going to explore that a little later on in the program and in the week. So stick with us. We'll be right back.
Welcome back on this lovely Monday morning or afternoon or evening, depending on where you are in the world. If you're just joining us, we are taking a look at Comet Catalina, a comet we're referring to today as the Naked Eye Comet because it's expected to become visible to the naked eye any day now, possibly. Bob Berman will be back a little later to tell you how you might be able to see it, assuming it becomes bright enough, but you should be able to see it through binoculars or a telescope. Now, our host, Bob Berman, just finished a fascinating interview with Jeff Chester of the Naval Observatory, if you're just joining us, where we learned all about how the USNO's work helps us every single day in keeping time, in using the GPS on our phones and in our cars. It's really wonderful, honestly, especially on a day like today when in the US, we're remembering the attack on Pearl Harbor, to see how the military assists people all over the world, even outside of war zones. And of course, here at SLU, we really like seeing how astronomy can be used every day. My name is Trisha Ennis, and I'm the resident cultural correspondent here at SLU. One of the things that you actually realize really quickly when you're looking at the history of astronomical study and understanding is that ancient cultures had a much firmer grasp on what exactly was going on in space than I think we like to give them credit. So today, for the start of Comet Week, I'm going to talk a little bit about how they looked at comets. Now, by the time we started keeping records millennia ago, early astronomers had already mapped the stars, named the constellations, they even named the planets, and they figured out the orbit and the phases of the moon. But understanding how things move doesn't always mean you entirely understand everything. And when there's something you don't understand, it tends to inspire an awful lot of fear and doubt. This was exactly the case with comets. You see, where constellations are constant and more or less unchanging, and planets, even meteor showers, are predictable and mappable, comets are much more sporadic and inconsistent, especially without the technology of today. In many ancient cultures, the skies were the domain of the gods, and the gods, the things that occurred within their domain, were their will. Planets were representations of those gods, but comets, they were harbingers. Most of the time, comets were not bringers of good news. Some thought they looked like the head of a woman or like a blazing sword, and these are not happy images. In fact, many believe they indicated the gods were displeased and were soon to unleash their wrath on the world. As with most beliefs, especially ancient ones, mythological stories fueled them and fueled the belief that comets meant bad news. They even appear in the most famous and oldest of the ancient stories, the Epic of Gilgamesh, where a comet was said to be the first indicator of the deluge, or the Great Flood. But myths and legends weren't the only place that comets were said to bring about bad news. Pliny the Elder, the famous Roman philosopher, believed comets signaled unrest or death, political unrest or death. And in fact, some Romans believed the comet, any comet, appeared just before the death of Julius Caesar. Halley's Comet, specifically, meanwhile, has been blamed for any number of catastrophes. In Switzerland, it was blamed for earthquakes, red rain, and a number of other strange occurrences, two-headed animals at one point. In England, some blamed the appearance of Halley's Comet for bringing about the Black Death, which was responsible for the deaths of between 75 and 200 million people worldwide during the Middle Ages. And Pope Calixtus III even went so far as to excommunicate Halley's Comet as an instrument of the devil. No word yet on whether they've made up. To this day, and despite all that we currently know about comets, they remain objects of concern or turmoil. In 1910, when the Earth passed through the tail of Halley's Comet, people all over the world reacted in a variety of ways, from the comet dinners put together by Parisian restaurants to packed churches in the US, where parishioners believed the arrival of the comet signaled the end of time. People wrote to the Royal Observatory asking whether it was safe to travel by boat during this time because they feared the comet might cause severe storms. The observatory, of course, told them they had nothing to fear, as you might guess. And now that we've learned a little bit more about the cultural significance of seeing a comet in the sky, I'm going to turn it right back over to our host, Bob Berman, who can tell you how you can see this comet in the sky, possibly tomorrow morning.
Absolutely. That's fascinating, Trish. That's really great. Trish is just, you know what she has been bringing to SLU? The cultural, the ancient, the superstitious lore, legend that gives us background to all the celestial objects that we explore. It's immensely valuable here at SLU. As we look at our SLU observatory image showing the comet with its strange anti-tail, comets. As they heat up, as the ice melts, doesn't really melt, turns to gas, the solar wind, charged particles from the sun blowing outward at typically 300 miles a second, blow the wind back like a windsock. And so you have the tail facing away from the sun at all times. And that's the typical comet thing. Now, Comet Catalina whipped around the sun on November 15th, just a few weeks ago. The tail's behind it, but sometimes a comet develops an anti-tail pointing more or less toward the sun. Weird thing. That's what we're getting here. We're getting tails in different directions, and really strange thing. Also, there's a plasma tail and a dust tail. This is very cool stuff. So we're going to keep watching it. Every day it looks a little different. So our SLU members and our SLU telescopes are continuing to monitor. Now, here's how you can yourself. Honestly speaking, we all remember Comet Ison 2 years ago. It turned into a bust. It was thought to be maybe it'll be the comet of the century. It was one of those busts of the century, just as Comet Kohoutek was back in the early 1970s. So you never know, mid 1970s actually. So you never know what a comet will do. We always know where it will be, but not how bright it will be. Now, honestly speaking, a few months ago, I would have told you that this comet by now, as it's reappearing in the morning sky, for those of us who live in the northern hemisphere, it's now entering the best time to be observed. The moon is leaving the scene. It was near the comet this morning, but just a couple of days that'll be gone. The skies are leaving the comet in a perfect theater for observation. The comet's getting higher every day and it's moving north, which is great. Right now, it's moving from the direction of where Venus is located. That's the brightest star in the morning sky, up towards Arcturus. You can always find Arcturus. It's the brightest spring star. It's a little orange looking. And if you follow the curving arc of the handle of the Big Dipper, you arc to Arcturus. That's kind of astronomy 101. So you can find Arcturus. The comet's moving from Venus towards Arcturus. Just sweep binoculars in that direction. If you have a small telescope, point it there. Or if you really want to get lazy, just wait till the last day of the year, December 31st and January 1st, and the comet will be right next to brilliant Arcturus. What could be easier than that? Just point binoculars its way. Try it with your naked eye. We don't know what's going to happen brightness wise. Right now, it's sixth magnitude. Now, that's tough. That's too faint. You can't see sixth magnitude. No, no, no. Because sixth magnitude star, that would be the same brightness as Uranus currently is. You'd barely see that, and that's a point. Once you're talking about light that's smeared out a little bit, the way comets are, the surface brightness is below sixth magnitude. Will not see it naked eye, but will it brighten up? It stopped brightening. Will it now resume? It can. It could easily do that. And then it could become naked eye. Just be on the safe side. Use binoculars, use a small telescope. Now you know which way to look. Pre dawn, get up an hour before sunrise. You'll find the brightest star in the sky. That's Venus. Look above it. That's where the comet is. Look in a direction from Venus to Arcturus, that bright orange star, the brightest orange star that's above Venus. And again, you could confirm that by following the arc of the Big Dipper's handle, arcs toward Arcturus. That's where the comet will be on the first day of the year. So that's how you can look for it yourself. Maybe it'll surprise us and get bright enough to pop with the naked eye. Otherwise, binoculars will do it. And if you have a small telescope, well, sure, use it. But no matter what you use, stick with us here at SLU because we're going to keep tracking this thing. And look at this view. You're not going to see that yourself. We need a bigger telescope for that, and that's what we're doing. And you'll notice that the tail structure and how many tails it has and all sorts of details like that will change day by day. And that's one of the reasons that it's so exciting to see. And this is just part of Comet Week. You know, what we've learned today is what the comet is, what comets are, their cultural significance, and we had a great talk with Jeff Chester of the U.S. Naval Observatory on what they do, and amazing stuff. We're going to have him back, I'm sure of that. So we're going to continue Comet Week all this week. This Thursday, a few days from now, we're going to be looking at Comet 67P through our Canary Islands telescope, and we'll be looking back at Rosetta's year of the comet. Remember, the European Space Agency landed there, still has a craft on the surface and one orbiting it. So it's giving us our best ever views and information about comets that we've ever had. We're going to do live telescopes, all the time. Then on Sunday, this is the year's best meteor shower, the Geminids. We're going to have a special show on Sunday night. I'll be back here, but we're going to have feeds from various parts of the world. We're going to see those live meteors. And I mean it, the best meteor shower. The media, not meteor, but media like to say, hey, go out and see the meteor shower tonight or tonight or tonight. And very often they're talking about minor showers, like the way the Leonids were a few weeks ago. These are skimpy meteor showers where you might see a few an hour. But this is the real thing. Coming up on Sunday night, the Geminids will put on 1 to 2 meteors per minute. And we'll bring that to you. We're going to show you how to watch it for yourself and then hopefully listen to us while you watch it. That way we'll kind of narrate the cool stuff about the meteor shower. And it is cool because these are the strangest meteors of all. The object that's causing it, something named Phaethon, is still poorly understood and strange in a lot of ways. So, and if all of that's not exciting enough for you, we've also just launched SLU's Star Share camera. Now, this is a new feature that'll let our members look through all of our feed partner telescopes during shows. You can see them all, and during our live telescope hours every night, just click on the feed you want to see. Zoom in. You can kind of be your own producer. Snap a picture, personalize it, and share it with your friends and family. Those of you watching on our 24-hour channel will return you to the best of SLU's past broadcasts. You can catch all sorts of content on the channel, including live feeds from SLU's network of observatories. Very exciting. It keeps going. SLU will present Comet Week all this week, and of course, all sorts of other cool astronomy stuff as they unfold all the time. I'm Bob Berman for SLU. Good night. Those who are joining us from our 24-hour channel. That's the live channel that allows our members to enjoy around-the-clock entertainment from the folks here at SLU, from live telescope feeds to the best of SLU's past broadcasts, and even a few videos teaching you how to take advantage of the objects visible in the night sky. So we're here to explore comets this week. We have a special guest here that I'm very excited about. And let's start right off with, why comets? Why are they so special? And the answer, of course, is they've been astonishing people for thousands of years. It used to be bad news. Comets were not anything you'd like to see because they supposedly brought bad luck. They were scary, and they're still awesome in not the sense that everybody uses that word. Recently somebody at a 7-Eleven gas station asked me if I had exact change, and I said, yeah, here it is. And the guy said, awesome. And I said, no, 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 no. The Grand Canyon is awesome. Exact change is not awesome. But comets are awesome. And don't even ask me why. They're skimpy. They're mostly water droplets. They're ice. If you look at it on paper, you wouldn't think that they'd be so amazing. And yet, you take a look at a good one, a bright one, and Well, hi everyone. This is SLU. I'm Bob Berman, and we're here to explore Comet Week. Welcome, everyone. Especially, it is awesome. We've last had a really bright one back in 1996 and 1997 when we had two in consecutive years, Yakutaki in 96 and the Great Hail Bop in 1997. Once every 15 to 20 years, we get one that's called a great comet. And that adjective does not mean, hey, look at that. It looks great. It's an actual scientific term that means a comet bright enough to be seen by the naked eye without equipment, even seen over cities. So we were thinking that this comet coming up might have qualified, Comet Catalina, which is our focus today. And